The second type of claim we look at is where we're given a claim comparing numbers from within one group. This could be something like more people have an iPhone than a Samsung phone. The rule of thumb formula for the comparison within one group, 95% margin of error, is 2 times 1 over the square root of n, where n is the sample size. The reason this is multiplied by 2 is that each of the groups has a variation of 1 over square root of n, so that to account for both groups we've multiplied by 2. A reminder, this formula only works where both the percentages are between 30 and 70%. Outside of this range, the margin of error is smaller. You can't use it if either of the percentages are outside of this range. Let's look at another simulation. For group 1, we've said the population proportion is 55%. For group 2, we've said it's 35%, and we've got a sample size of 100 again. We can see in this first simulation that we've run, group 1 had a percentage of 49, group 2 had 40, and so the difference between them was 9%, which is nicely graphed down here at the bottom. Let's take another sample. This time we had 51% and 38%, which gives us a difference of 13, which is graphed down the bottom. What we can do again, just like last time, is we can have the simulation go through and do it 1,000 times. And we can see this distribution of differences building up. We can see occasionally we get some really small differences or negative differences, and occasionally we get some really big positive differences. But 95% of the time we're getting a difference between 2% and 37%, which gives us a margin of error of 17.5%, which is very similar to our rule of thumb of 20%. Likewise, in the previous example, we increase the sample size. If I increase this again to 1,000, and make it happen much faster, we can see that our margin of error has got much smaller. Likewise, if I make these percentages more central, we can see that that margin of error is just a tiny bit bigger. And likewise, if these percentages get quite small, we can see that the margin of error is very small and doesn't line up with our rule of thumb, which is why we have to stay between that 30 and 70%. If you want to have a play with this simulator, again it's linked in the notes. Let's have a look at an example for when we're making a claim with a comparison inside a group. Let's look at this claim. More Kiwi students have an iPhone than a Samsung phone. We're given some extra information as well. The survey questioned 770 people, 40% said they owned an iPhone, and 33% said they owned a Samsung phone. Looking at this, we can see that the number of people who said they owned an iPhone was 7 percentage points higher than said owned a Samsung. We need to see if this 7 percentage points difference from the sample is actually enough for us to conclude there is a difference back in the population. Just like last time, there are 4 things we need to do. The first thing we need to do is find the margin of error. This is 2 times 1 over the square root of n, which is 2 times 1 over 770 square rooted, which gives us 0.0721 to 3 significant figures. If we make this a percentage by timesing by 100, this is 7.21%. Now we need to construct the confidence interval. This is 7% plus or minus our margin of error of 7.21, which gives us a bottom of negative 0.21% and a top of 14.21%. Now we need to interpret what this means. It's a fairly safe bet that the percentage of Kiwi students who own an iPhone is somewhere between 0.21 percentage points lower and 14.21 percentage points higher than the percentage of Kiwi students who own a Samsung phone. And now we have to make a judgment. This confidence interval does not support the claim that a higher percentage of Kiwi students own iPhones than own Samsung phones because 0 is contained within the confidence interval. Again, it's really important that you keep these last 2 bits as separate sentences. With this, there are 3 types of judgments we can make. We can say the confidence interval does not support the claim because 0 is contained within the confidence interval. We can say the confidence interval does support the claim because the confidence interval is entirely positive. Or we can say the confidence interval supports the claim because the confidence interval is entirely negative.